Let's look in this unit on how Wi-Fi networks work. So Wi-Fi is a commercial term that is nowadays used as a synonym for wireless connectivity. A Wi-Fi link connects a user to a wireless local area network using a radio frequency channel. And all devices connected to the same access point are in the same local network, and so they can share resources. Wireless local area access points can be connected to a wired network to cover a bigger physical area. And in lots of cases, this wired connection also connects users to the internet. So nowadays, multiple devices, as we can see on the slide, incorporate technology to connect to a Wi-Fi network and share information. Computers, smartphones, tablets, cameras, video game consoles, and much more devices nowadays incorporate Wi-Fi. So the standard that regulates this connection is the IEEE 802.11. And this covers the media access and physical layers. And there are actually now several versions of the standards, and newer versions have been developed to add more features and bigger bandwidths. So each of the Wi-Fi standards define a set of radio communication channels that is one or several bands of the radio spectrum. And the bands used by Wi-Fi are free use bands, in which every application must tolerate the interference of other applications. So this means that Wi-Fi is prepared to work with interferences from other applications. And this is important because, for example, the 2.4 GHz band that is used widespread for Wi-Fi is known as industrial, scientific and medical radio band, and this is also used by microwave ovens, cordless phones, Bluetooth devices or medical devices that use radio frequency. So the odds are that the biggest interference you will find when using Wi-Fi will actually come from other Wi-Fi users. There are a few channels defined for Wi-Fi in each band, and in the most used band, the 2.4 GHz, the 13 channels defined are overlapping. So only 3 of them can be used in the same area without interference, as was depicted in the former slide. So as almost every home user in the Western world has its own internet connection with a wireless router nowadays, you can find yourself in a situation as the one you can see on this slide, that you captured with the Wi-Fi. This is captured with the Wi-Fi Analyze program in the United States home. And in this situation here, you can see a laptop that indicates that you have a very good Wi-Fi signal, but the connection speed will be poor. And this is because you probably will be suffering a lot of interference from other Wi-Fi users. It's very likely that the new Wi-Fi standards that offer higher bandwidth using 2 or 3 channels will even make things worse in the future. So the corporate networks have the same cellular structure as in cellular telephone networks that is used to cover large areas. And the 2.4 GHz band requires very careful planning of frequency reusing and non-adjacent cells, because there's actually only 3 non-overlapping channels. So the 802.11a was defined in 1999, and it allowed speeds between 1.5 and 54 megabits per second using the 5 GHz band divided in 12 or 13 non-overlapping channels. This has been used more in North America, as at first this band was reserved for other applications in Europe. So this band has the advantage of being less crowded than the 2.4 GHz band, and it has more non-overlapping channels. The disadvantage is that it has less range and penetration of obstacles because it has a higher frequency. So the 802.11b family was defined in 2000 and transmits data at 11 megabits a second. So this uses a different frequency band, which means that it's incompatible with 802.11a. It defines 14 channels, of which only 11 can be used in the United States, and these channels overlap. Only 3 of them can be used at the same time. So this band has been used intensively around the world and actually suffers from saturation nowadays. So then there is the 802.11g. This is an update of 802.11b using the same band. And it's backward compatible with 802.11b, and it's incompatible with 802.11a. So another family was defined in 2007, which is the 802.11n. And the main improvements over previous standards are that it can handle more than one antenna in the same device using a technology that's called MIMO. And this stands for multiple input, multiple output. And it reaches up to 600 megabytes a second. And for that it uses several channels, and what can be a problem is that it has the saturated 2.4 gigahertz band. So this standard is widely used in all the world, and it's backward compatible with all the previous standards we've seen in the previous slides. So the most recent specification refers to the AC family, and it uses a different band at 5 gigahertz. It's faster, but more sensitive to obstacles. It can reach 1 gigabyte per second, so it's fast, but it's still new, and devices that incorporate it are still a bit expensive. So an avoidable issue in wireless communication is that the radio signals are sent using the open space. So we should use systems to ensure that only authorized people can use an access point and that nobody can eavesdrop on the connections. And because of that, there's different protocols that ensure authentication, authorization, and accounting of users. And the most updated ones are called the 802.1x for authentication and WPA2 for authorization. So the common way to connect to a Wi-Fi network is using a Wi-Fi hotspot, which is also called a Wi-Fi access point. And it's getting actually more and more frequent that these points exist and provide wireless access in public places like hotels, airports, libraries, or even in open areas like on the street. And some of these hotspots offer free internet access and others charge a little bit for your connection time.